I almost don't want to record this meeting because I'm missing almost half of my class. But does anyone have any questions from homework? We went over a few things earlier during office hours. Any questions from homework? All right, I guess, okay. I hit everything for everybody during office hours. I am in a little bit, I'm gonna probably wait for more people to show up. I'm gonna show you how the quiz is gonna work. So I'm just gonna hold off on that until more people show up. And if nobody has any questions, I'm gonna jump back into finishing up something from section 1.4, and then we're gonna get into section 1.5. It's crazy. Okay.
I have a quick question, and
Yes.
I think that I've just been tired and acting stupid lately. After numbers in the parentheses, and then the I guess what is that, an exponent, whatever, like a squared number. It needs to be squared to the because I think I've been messing that up completely.
That is one of the ones. That's one of the questions that I was going over earlier. So this is good because I think a lot of people messed up that one problem. So let's take a look at this. So there is a difference between this problem and this problem. Those are different. So let me ask you this real quick. Let me start over here. So up here, look up here. We're going to look at this in a minute. 1, 2. But first, a note. Can somebody tell me what 2 times 3 squared is? What's 2 times 3 squared?
18.
18.
18. Can you see why somebody might say 36? If you're a teacher and you see somebody say 36, can you figure out why they thought it was 36?
They multiplied 2 times 3
times 2.
Yeah, those crazy people. They did this first, and that's insane because you don't multiply before you do exponents, right? So this is 2 times 9, 18. So look at what number 1 says here. The negative is just like the 2. It is negative times 3 squared. So I don't have 2 negatives. I have 2 3s. So if I wanted to write this is a negative sitting in front of 2 3s. So what is that answer?
-9.
Negative 9.
That makes sense. 3 squared is 9. So negative 3 squared is negative 9. Easy. What's the difference on number 2? Well, what do I have 2 of now?
Negative 3s.
2 negative 3s. Oh, crappity, dude. Come on, pen. So what's that going to be, of course?
9.
9. I love it. I love it. Do you guys see that? It's order of operations and you don't even realize it. Exponents comes before multiplication. Wait a minute. Okay. Which section are we talking about? 2, 3, and 7 from where? Somebody's asking me a direct message question. 2, 3, and 7 from what section? All right, 1-4, I guess. 1-4. All right, I love you. The last homework, I don't know what the hell it means. Let's see. No, 1-3. All right, am I gonna guess all day? Do you know what section it's from? 2, 3, 7, 1, 3. Okay. All right. Let me see. Where am I at? Am I in 1, 3? Yes. Yeah. So a lot of people had trouble with these. Oh, you're okay. I'm sorry. I'm in a bad mood this morning already. That's not a good start, but oh, too bad. I don't. All right. So these you just have to slow down. These are problems that you could hit in real life. So he starts at 160 pounds. He gains 0.25 pounds every month. So how much weight would he gain in 2 months? 2 months, how much weight would George gain?
Half a pound.
Yeah, 0.5 pounds. So he's going for 4 years. So if I just knew how many months that was, I could do what you just did, right? So if I know for 2 months it's 2 times 0.25, for 3 months it would be 3 times 0.25. Well, it's going for 4 years. How many months is that? How many months is 4 years?
48.
48, because every year has 12 months in it. So now for 48 months, so how much total weight will he gain then?
12 pounds.
0.25 times 48, which is 12 pounds. So then you can tell me how much he weighs at the end of that. And then the mistake people make on the second part of this is after graduation. Well, he weighs the new amount now. Then you go for 10 more years. 10 more years of gaining weight, right? And this is how it works, all you young people out there, unfortunately. Is that all right? So don't start with 160 when you get down to this part. You got to start with the new weight because it's after graduation. Has anybody have you guys ever heard of the freshman 15? Anybody?
Yes.
Yeah, so that's the mythical, the mythical 15 pounds that freshmen gain. It's not precise, but it's pretty close to true. But anyway, on average, right? Not everybody. Of course, now with the pandemic, who the hell knows what that is? Everybody's gaining weight. All right. Is that all right? And then you said number 3 works the same way. These all kind of are the same problem in a way. Number 3 says to lose 1 pound, you need to burn 3,500 calories. Right? So let me see. How can I say this? So let me ask you this. Here's a different problem, not number 3. Let me do a different problem. If to fill a crate, you had to put 8 boxes in this crate to fill it, right? How many boxes would it take to fill 13 crates? That's a different thing. Or maybe I want to go the other way around. I don't know. I'm not sure if I can make a perfect example. I don't want to do exactly that problem because that's your homework problem. Let me think about this. Oh, I see. All right. Maybe I can make a different kind of problem. I mean, so let me ask you this. What's a good other problem I can do? Yeah. Let me do this. So if you can, in 1 hour, you can load 10 boxes into a truck. And the truck holds 3,600 boxes. How long will it take to fill the truck? So in 1 hour, you can put 10 boxes into the truck. It takes 3,600 boxes to fill the truck. How long until the truck is full?
36 hours.
How?
600 divided by 10.
Yes, it'd be 3,600 boxes divided by 10 boxes because that's per hour. So now this would be 360 hours. Woo! Does that make? Sorry?
Why you can't give us the answer for this question, even though the due date is in the 14 and we already have a due date for this homework?
I don't care. Not everybody has done this yet. So I want them to do this problem.
Oh.
I don't want to do this problem for you. But what I've done, I want you guys to realize it's 1 pound of body fat. You have to burn this many calories, right? If you burn 450 calories each day, right? You're burning 450 calories each day. How long will it take to lose a pound? How long will it take to burn 3,500 calories? It's exactly the same problem as this. You do the exact same math. I mean, all right. If it was 900 calories to burn a pound, and you did 450 calories a day, how many days until you burn a pound? If it was 900 calories to burn a pound. Yes. Do you guys see that? Wouldn't it just take 2 days? Wouldn't that just be 2 days? In 2 days, you will have burned 900 calories. 900 divided by 450 is 2. So it's not 900, it's 3,500. So you do the same thing. You do the exact same thing. So these are problems about, okay, you got some numbers. Can you figure out what to do with the numbers? So sometimes making the numbers prettier helps your brain latch on to what to do. No? You guys okay out there? To lose a pound, I've got to burn 3,500. So 2 days, I get to 900. 4 days, I get to 1,800. Well, how long until I get to 3,500? Well, that's going to be division. Some of you guys were estimating. No. I want to see the actual operation division. I mean, you don't have to do long division, but you got to tell me what the hell you're doing. You guys okay out there? Is that all right? Number 3?
Quick question on
Yes.
that one.
Yes.
I mean, I don't know if I got it right, but can you estimate like the days, like say if it was like 7.8 or 8.7, whatever, can you push that up, round it up?
I mean, technically, but why? Because then it'll overestimate what you need for 10 pounds. Do you see what I'm saying?
Got it. I just did both answers anyway.
Yeah,
But
you're
I
good.
did-
You're good.
Okay.
Yeah. You could put both. You could say, well, if you're okay with estimation, then,
Okay, thank you.
yeah. And number 3 is a perfect example where estimation would be fine because there's no way in hell you could burn exactly 450 calories more every day, right? I mean, I don't care how much precise. Oh, I can't move anymore today. I've already burned 4. I can't breathe. Oh shit. No. I don't know if you guys are with me. And then the other question was number 7. Now these are really cool. I love these problems, and I would love these problems. Can somebody tell me here? I'll give you an answer. You ready? You guys tell me. What'd you guys get for number 5?
72. Oh,
No.
50
Yeah, 50. And what are there 50 of?
square.
Squares. 50 little square units. So that's why area is measured in square units, because I want to know how much covers something. And how do we cover something? Well, the easiest way to cover something is with little squares. Whereas how do you fill something is with little cubes. So number 6 and number 8, I basically just answered that for you, if you were paying attention. Okay. So this goes beyond the volume formula. I don't want to see the volume formula. They're not asking for the volume formula. They're saying count the number of cubes. That's what they're saying. Right? So it's kind of going more basic than the volume formula. Okay. That's why I love this problem. Basic not meaning easy. Basic meaning getting to the underlying idea, right? All right. How you guys doing? You guys all right? You guys are like, damn, big old long weekend, and then math just slams you in the face. Sorry. Any other questions? You guys all right? All right. There's one more thing I want to talk about in section 1.4. I was so focused on the interest, I didn't do something more fundamental, and the homework kind of gets at this. Let me find some white space here. So I want to show you something kind of cool. We basically learned this if you were paying attention, but if I want to increase the price of something by, I don't know, 5%, right? So if I have it originally as $80 and I want to make some money, I'm going to sell this in my store. So I'm going to mark it up by 5%. Or if I'm the bookstore, I'm going to mark it up by 34%, right? A shortcut to figure out what the new price is. Let me see if you guys are with me. How would I figure out? Let's do this. How would I figure out what the new price will be? I'm going to increase the price by 5%. How much will I increase it by? How would I figure that out?
Would you multiply by 0.05?
Yeah, so you do 5% of 80, right? So 0.05 times 80. And then you're going to take that and add it to 80. Right? Isn't that what you would do? Okay, maybe. So then what's that? Is that 4? I don't know. Wait, who's talking to me? Yeah, so it's $4, so it'll be $84. Kind of a shortcut to that, kind of a shortcut to do all this is to do one whole thing plus 0.05 of that thing. So 1.05 times 80. Somebody do 80 times 1.05. What do you get? So it's like one whole 80 plus 0.05 of 80. What is 80 times 1.05?
84.
84. I like it. So that's a shortcut. And what's really cool about this is, what if I want to increase the price by 5%, but I want to do it 11 times? So I want to start at 80 and I want to increase the price by 5% 11 times. Does that start to look more familiar? That's basically the interest formula, right? The compound interest formula. But all that does is it applies a 5% increase this many times. That is beautiful. Uh-oh, I get chats. This is not good for me. Hold on. Oh, okay, good. Somebody just told me the answer. So how do you do this? Can somebody do this in the calculator? What is 80 times 1.05 to the 11th power? I'm going to guess it's $138. I don't know. I'm totally making that up. Can anybody, do you guys know how to do that? Can you do 80 times 1.05 to the 11th power? Ooh, that was close. Anybody? Anybody? It's a rough day, man. Let's see. Yeah, okay. Does anyone not know how to do this in the calculator? If you don't know how to do this, you can't do section 1.4. All right, got some more answers coming in. I like it. All right. Okay, so if you're not talking, I'm going to assume you can do this and you just don't want to tell me what the answer is. Okay. Jackson, what's up?
Really quickly, I'm just wondering when we need to show like long division work or multiplication work by hand on the
You don't
homework.
anymore. You only had to do that in the very first assignment, but that doesn't mean you don't show work. Work means exactly what I'm writing here, exactly what I'm writing here, exactly what I'm writing here. That's work. Work is showing me what you're going to put in the calculator.
Okay.
Yeah.
And then
I'll
I'm
be very
also
specific if I want you to show me more by hand than that. Yeah, go ahead.
I missed your explanation on the cubed, counting the cubes.
Oh, well, you basically just
problem.
answered it yourself. Why is volume in cubic units? Because we are actually just counting cubes that fill a space. That's why it's cubic units. We're just counting the number of cubic units that fill a space.
Okay.
That's why volume is in cubic units. Yeah.
Thank you.
You're welcome. All right, guys. Maybe. I'm going to clear all this away. So if you haven't tried section 1 for homework, hopefully that helps a little bit. Real quick, let me do this. Let me ask you guys, if I got a 25% discount and they gave it to me 4 times, will it be free? Right? I hear this all the time at a store. I go to a store and they say it's a 10% off sale and then there's 20% off on top of that. So it's like 30% off. No, it isn't. No, it isn't. I really want you guys to understand. Let me see. Yeah, no, it's not. Let's figure out what the hell it's going to be. So something starts off at $100 and I give a 25% discount 4 times. Here's what that would look like. A whole thing minus 25% 4 times. I really want you guys, that's a beautiful shortcut. So it's a whole thing minus 25% 4 times. Can you guys do this in your calculator? No, I want to know. Let's see what this is. Neato. Yeah. 3164. Now, people will go to the store, they'll see 25% discount and we'll give it to you 4 times over. And they don't say anything else. And people are like, holy crap, that means it's free. And then they get to the checkout and it says, no, it's this much money. And they're like, all right, I might as well just get it. I mean, that's not, they don't do it that blatantly, but there are stores that allow you to think things. And then when you get to the checkout, they're like, well, this is how math works. And like, oh shit, all right, here's my money. Has anyone ever experienced anything like that at all? Where you thought it would be less and then they're like, well, no, too bad. No. No, okay. Good, all right. Let me clear all that away. Okay, anything else before we get into new stuff? Anything left over? Oh, let's do this. Before I get into new stuff, let's do this. Let me show you what the quiz is going to look like. I'm going to show you one of my other classes just so I can show you a quiz. So here's what's going to happen. Well, let me pull these guys up. Here we go. All right. Oh, is this one going to be? Wait a minute. Let me do this. Reset student. There we go. So guys, the quiz is going to unlock after class. You can start it anytime you want to. I know this is my 176. I don't care. It's going to look the same. In your modules, there's now a quizzes module. When you click on the quiz, there'll be some instructions. Don't read these because this is for another class, but there will be instructions right here. There's a little button that says take the quiz, right? When you hit that button, you'll have an hour. And it starts to count down. If that freaks you out, this little countdown, you can hide it. Okay. Down here, you can click here. If you want to download a copy, you can print it out. You can do the work on the sheet, or you don't need to do that. You can do the work on another piece of paper. When you are done, so you'll see the quiz here. This is my pre-calculus quiz. Don't get excited. When you're done, you're going to type in here the time you're done and hit submit quiz. Now notice you haven't submitted work yet. Are you with me? And I'm really sorry this has to work this way, but it just does. So now you go back to the quiz module and it says submit quiz 1 here. This is just like turning in homework. You're going to scan your quiz work. You're going to submit it the same way you would with homework. You guys with me out there? So it is timed, but it's not due until tomorrow morning. I think I made it 8 a.m. so that I have a good chance to possibly grade them all. Hopefully a decent chunk of you guys do it today. That would be awesome. But you'll have until 8 a.m. tomorrow to do it and turn it in. And the minute you start it, you get an hour to do it. Okay. Any questions about how it's going to work? All right. I just have Trisha's face to go off of for reactions. I have no idea what anybody else is thinking. Genius, what's up? Did you have a
no,
question?
I just said sounds good.
Oh, okay, okay. All right, there's Trishan giving me a little thumbs up. And then everybody else could have went back to bed. I have no idea. All right. Let me stop sharing. Okay, so let me turn off the Death Star. I love being able to say that. Let me also address this real quick. I have no idea if you guys have noticed anything about my physical condition. Has anyone noticed my eyeball yet? You guys see that? Eyeball, eyeball.
I've had that.
What happened?
So I apologize ahead of time if you don't want to hear this. But just real quick, this is exciting, kids. One more thing that can happen to us humans. 2 years ago, I lost sight in this eye. Lost like 70% of the sight in this eye, just out of nowhere. I was coming back home from Temecula. I think it was the Cuban coffee. I went up there to meet some friends. We had some Cuban food, had some Cuban coffee, and then my eye just decided to stop working. That's fantastic. So it was sort of like looking through a shirt, you know what I mean? Even worse than that. So I went to the hospital, and now every 7 weeks, and I apologize for this, I have to get a shot in my eye. So every 7 weeks, there's a chance it could be red. Sometimes it's not even red at all, and sometimes the whole thing is red. And those days are awesome because I'll go to a store and I'll forget about it, and the cashier will be like, "Do you have any?" I'm like, "I'm sorry." So anyway, so if you ever notice that my eye's all red, every 7 weeks I got to get that shot. So it actually has gotten a lot better, but I can't see details, to be honest. But at least I can see something. And there's a 5% chance the other eye goes out. That's fantastic. That keeps me up sometimes, but you know.
Does it hurt? What's in the shot exactly that prevents it from? Lets you see.
The shot actually keeps the swelling down, and it gives it a chance to heal, and it seems to still be getting better. And the minute it's not getting any better, they will make the shots like every 4 months or something. But right now it's still healing, so it seems to be getting better. So we're going to continue on the 7-week thing. When this first happened to me, I had to tell my students because they would come up to give me papers back in the days when we were in classrooms, and I would reach for the paper and I couldn't grab it because I had no depth perception. It was so weird. So now this eye has taken over and I have depth perception again, but now it doesn't matter because everybody's submitting things electronically. So I don't need to reach out and grab it. Anyway, just to address it in case somebody sees that and they're like, "What the shit?" Okay. So that's that. All right. So let's get into the next section we're going to get into is all about graphing. And normally students' hatred of algebraic topics goes something like this: word problems, graphing, order of operations, everything else, right? Something like that. So we're going to ease into graphing a little bit. Let's see what the book has for us here. Let me move you guys over there. What do you guys, let me start off like this. Let me do this generally. When I say graphing, what do you guys think? What comes to mind? When I say graphing, algebra stuff, what comes to mind?
XY axis.
XY, I love it.
Slope.
Slope, I love it.
Parabola.
Sorry? Did you say parabola?
Parabola.
Parabola? Parabola or hyperbola? Hyperbola?
Parabola, whatever.
Parabola? Not just one bola, but a parabola. All right. All right. If you don't know what the hell a parabola is, don't worry. I think most of you probably have heard of it, right? Little U-shaped dude. So yeah, graphing, I love it. Graphing, when I say it, we normally think two-dimensional graphing. That's the XY plane, right? We think points plotted in the plane. Then we think about lines, which comes up with slope. Then we think about parabolas. We think about what about curvy lines? And then what would those equations look like? And so forth and so on. Okay, 11. So we did one version of graphing was like pie charts and bar graphs. But when you think graphing for algebra, you think lines and slopes and XY. I love it. Exactly. Okay, so let's get into the book. Let's see what they got here. There it is. Come here, 1-5. Where are you? 1-5 Kenobi. All right, here we go. Yeah, barf, 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 barf. Barf, 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 barf. Look here real quick. All right, they make it sound all official. A time series graph, whoop-de-doo. That's just going by year, right? So over the years, what was the unemployment rate? Is that what this is, right? Let's see. Barf, 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 barf. Unemployment, okay. Can somebody tell me the trend from like the early 90s to the beginning of the 2000s? What was the trend in the unemployment?
The trend was somewhat
decrease
down and then up.
Yeah, so up to this point, it was going down. Right, this is the dot-com boom. This is when the economy is going crazy. And then, of course, once we hit 2000, we won't discuss anything political, but the unemployment rate started going back up. And then what happened? Does anyone remember what happened around here?
The stock market crash.
Yeah, recession, housing bubble popped, all this kind of business. And we thought that was bad. And now we know it was nothing, right? Compared to what the hell we've been through. Okay. So that's, I went a little deeper into the actual content than I needed to. But you can tell trends, but it would be much easier if I could look at a graph. So here's the graph of the same data. Now I can really see the trend much easier. That is the most basic reason why we graph data points, is so I can get a very quick idea of decreasing and increasing. You guys with me? Of course, if I kept going to 2020, this thing would just kind of skyrocket.
Thank you.
Sorry?
Not on my computer. Thank you.
What's happening? Oh. Let me mute you, Trisha. There you go. Okay. Oh. All right. Blah 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 blah. Okay. No, I don't care about all this. Oh, somebody's chatting at me. Oh, you're okay. All right, now. How do I create such a graph? What are each of these dots? Come back up here, right? Like right here, this is a point, right? So this is the point 92, 7.5. Let me see here. Let me put that up here. So this is the point 1992, 7.5. So you can see exactly, right? So I think coming into this class, I do believe that everybody should be able to plot a point on an XY plane, correct? So if I gave you an XY plane, right, 1, 2, 3, 4, and so forth. And I said, plot the point 2, -1. Could you do it? Could you plot the point 2, -1? How do I do that? Where do I always start when I go to plot a point? Where do I start?
The
X.
axis.
how does that mean? What point do I start at?
The 2, so the positive 2 on the
No, no, no,
x-axis.
I see what you mean. I see what you
0.
mean. You're looking at
0.
this. Yeah, but we always start at the point 0, 0.
Yes.
And that's appropriately named the origin because that's where I always originate my movements. Now, I love what you guys are doing. This is X, Y. Points are always in alphabetical order unless otherwise stated. So if I had A, B axis, the points would be A, comma, B. Okay, I like it. Because X and Y are just dummy variables. I don't need to use them. So where would the point 2, -1 be? I would go from this point here. I think you guys started telling me. Which way would I go?
Right.
Right.
I go 1, 2 on the X direction in the X direction. And then I would go
Down.
down 1, and then I would put my point.
Yeah.
So right there, kill that 2. Okay, okay. That needs to be something that we can all do. Where would this be? Where would the point -4, 0? Where's that one? Let me do this. We call this A. I'm going to call this one B. Whoa.
Down.
Where
on
would this, sorry?
Just go down 4.
No. The first tells you which to move in what direction.
In the X. And
On the
so
X direction,
-4.
left and right. So the first
Left.
coordinate is always left and right.
Left.
So I would go left 4.
That's it. Here. At
Yeah.
the X line.
And the next coordinate is always up and down. So I go left 4, and then I wouldn't go up and down at all.
Mhm.
Does somebody remember what that kind of point is called? Why is that point special? Does anyone remember what the name of that point is?
X-axis.
X-intercept. This is where it intercepts the X-axis. I love it. So of course, where would the point, so that's B. Where would the points, get out of there, 0, 3 be? So now how much do I move left and right?
Neither. Go down.
Not at all. I love it. I'm just going to go up 3. So right there. Beep, 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 beep. So remarkably enough, that's called the Y-intercept because math people are creative, right? So we call it the Y-intercept because it's where it intercepts the Y-axis. It's crazy. Does this sound familiar to everybody, to anybody, right? You should be able to just plot points like a mad person, right? Just give me some points, Jeff. I'm going to plot those bad boys. So the first one's always left and right. The second one's always up and down. Okay, I like it. Kind of. Okay. Okay. I can work with that. So I'm going to clear all these away. It's going to go away. Bye, all you chicken scratch. Okay. I am recording, right? Yes. Okay. All right, here we go. Let's get a little more specific. Did I miss some definitions? I might have. No, who cares? Coordinates, they're the names for the points. Origin we talked about. This is a rectangular coordinate system. Real quick, there's like a circular coordinate system. And there is called a polar coordinate system, right? That kind of makes sense. The one that we use with XY is called rectangular because it makes rectangles. So that kind of makes sense. So here's your basic little graph you can use. You can have different scales. When you make a graph, you must show me. So if the problem asks you to make a graph and your answer is something like this, no, that's shit. You got to show me scale, right? You got to show me, like here, they show me that each one is 1 because they've identified this as 5. What about here? What's going on in this direction? What's each step? How big is each step?
2.
2. So that I can get up to 10, right? I like it. You got to show me scale and you got to show me work unless it's just a bunch of points they gave you, right? Now, the coordinates of the origin we already discussed, but do you guys remember? What's the coordinates of the origin?
0, 0.
0, 0, because I ain't moved at all. I like it.
Professor, I have a question.
Yes.
How it's work in this graph? The y is two step, and the x is only 1 step.
All right. I love it. Let me clear all this away. Let me remind you. Did you have any problem with this graph? In fact, you almost should have a problem with this graph, but do you see it? Except for 1992, isn't this all 5? And isn't this 2? So it wouldn't make any sense to force the 2 scales to be the same, because it really just depends on what my data looks like, right? So it's each scale by themselves has to be consistent. So I can't go 0, 2, 4, 20, 21, 28, 400. But I can have a different X scale and a different Y scale. They just have to be the same on their axis. Does that make sense? Otherwise, it would be almost impossible. So what if I had a bunch of points that look like this? What if I said plot these points? 150, 2, 150, 3, 300, 4, 500. I mean, can you, I really, so if the x-axis has to be 1, 2, 3, 4, and the y-axis has to be 1, 2, 3, 4, 5, and I got to make it up to 500? Holy shit. So can somebody tell me, if I had to plot these points, I think you all would agree that the x-axis can be going by 1. What would the y-axis, what should I use maybe for the y-axis scale if I had to plot these points?
50 or 100.
Yeah, I'd probably do 100, right? And 150 would just be in the middle, and 50 would just be in the middle, right? So 100, 200, 300, 400, 500. Yeah, and then I could find 150 would be about halfway up to 100. 150 would be in the middle there. All right. Does that make sense for everybody? The quickest way to make a science or math teacher cry when you make a graph is to have an inconsistent scale. 2, 2, and this goes up by 20, and this goes up by 1. Oh, we'll start to cry. Because what you're doing is you're being dishonest. Is that better?
Yes, but isn't it, if we do it in the different way, is the same, is different picture or different line will happen? No?
The shape doesn't change, but you got a good point. This is another place where people can be misleading.
Mhm.
So people can choose a scale to make something look not as bad or to make a difference look even worse than it really is. I agree. So normally what you do is you pick a scale that doesn't go too far beyond your highest point, right? So you're not minimizing things. I don't know how to make this make sense. So if I had to do this, I'm not going to go up to 80,000 if my highest point was 500, because then I might be trying to be dishonest. I might be trying to make it look like it's not changing as much as it really is. Does that make sense?
Yeah, but I mean the point, you know, the XY point, you know,
Yes.
the different, if we put is a 1 step or 2 step is a different. It's not in the same area.
Of course. I mean, anything we pick was an arbitrary choice to a certain degree, right? But there are, all right, how do I say this? So if I wanted to plot these points, could somebody use a scale of 10? Yes. On their x-axis, do you agree? Yes. They totally could. But then when I want to try to find 150, it would be way down here, 150. So now I am not doing a good job. And then 2 would be like right next to that. 250. I mean, so this would not make any sense because it goes way past the highest data value, the highest point. This would. Do you guys understand?
Mhm. Yes,
So
thank
if
you.
I think they get it, wait, do they do this later? Let me see. I'm sorry, I erased that too quickly, but do they do this later? I think they do. I can't remember. Oh, well, maybe they don't. Darn it. But if I wanted to make this look less dramatic, I could just go up higher. I really want, if the highest point, if I went up by, stay with me now, everybody. If I went up by 10 instead of, so if I went 10, 20, 30, right? Then this point would be 7.5. It would be like right there. So everything would look smushed and it wouldn't look like it was as big of a deal. It would make it minimize the difference there. So you don't want to make your scale so that you like go way past your high. So a scale of up to 12 here makes sense because the highest one was almost 10. That makes sense. But if you go up to like 40, 50, 60, that doesn't make any sense because then your whole picture is going to be down here and it's going to be smushed. Are you with me? So in general, how do you pick your scale? You pick it so that this one is just a little bit bigger than your highest X value, and this one is just a little bit bigger than your highest Y value. So you don't have like a lot of empty space and you don't end up smushing your graph. Okay, maybe. These are good questions. These are beautiful questions because picking a scale is sometimes very difficult. All right. Let me see. Where do I want to go? I don't care about this. Oh, all right. So you should be able to plot these points, right? So can you take a minute and make your own scale, make your own graph, and then plot those points? And then I'll do it with you. So I'm just going to use 1, I think. Should be good. Oops, my scale got bad down there, but too bad. All right. So if you want to get graph paper, you can. You can actually Google search graph paper and print it out if you want to even.
I was just texting that.
Oh, yeah. If you Google image search, you can get that. Or if you just search for graph paper, you should be able to find somewhere you can just print it out. If I were in this class, if I were a student in this class, I would make me get graph paper because look how pathetic my graphs are. Okay. So where is 40?
To the right 4.
Yeah, so go right 4 and go up and down none. So then I'll just be right there. I like it. So that's A. So when you do these kind of problems, label your little points. It makes it easier for me. That's point A. Now somebody else tell me, where's point B going to be?
Down
0, -8 down.
Yeah, so don't move left and right at all. I only go down 8. Jeff, you didn't give yourself enough. Bam. So that's -8. That's point B. So where is, so now -3, -4, I've got a couple steps to take. So I got to go -3. So that means go back 3. And then I got to go down 4. So that'll be right there. And that's point C. And then 2, 7. First number's a 2, so that's left and right. So go right 2. +7 will be up 7. So I'll be right there. And that's point D. Yay. Not too bad, right? You guys can eat that up. Now you could have done a better scale than me. One kind of got jumbled. You could have went by 2s, right? Make it a little less dense with tick marks. All right, let me clear this away. Here it goes. Bye. All right. Blah, 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 blah. This one is, yeah, I love this. Can somebody tell me what temperature this is showing me? Why can't you?
They didn't label it.
Yeah, I have no idea what the scale is here. And even the red and the blue are subjective, right? Maybe this is cool to me, or maybe this is warm to me. So I can't, what temperature is it? Lukewarm? No good. I need some scale here so I know how the hell to read that. So that's pretty much what they're trying to get to there. Now, same thing with number 3. What's the point? Can somebody tell me what point that is?
-2.
No, we can't.
You're making a lot of assumptions.
Oh, can't tell.
Can't tell. I love it. So you have to give me some idea of scale. Now, normally, if you don't have it labeled, I assume that it's going by one step each, right? But you have to give me some idea of what scale you are using. Because if you don't, I can't really tell what that is. But you did what I would do. I would assume you mean 1s if I don't see anything. Okay, maybe. Blah, blah, blah. And then they get really specific here with, oh yeah, this is a beautiful problem. Real quick. Oh, genius, what's up?
Just a quick question. When labeling, do we have to label each? Can I just, at the end, just say if it goes all the way up to 10, put like -10?
Yes.
So, okay.
Just like
So I
they
don't
did
have
on that earlier one where they had 5. Yeah, this one.
Oh, okay. Okay,
Fine,
got it.
then I can figure out what it is. Yeah. So then you're not getting all jumbled like I was on the one that I made. Yeah. Let me see. Blah, 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 blah. Okay. So here, real quick. Look what they did. Why is that 0, 1, 2? Because 2006 is 0 years after 2006. So this is just making it better for graphical purposes, graphing purposes. Instead of putting the whole year, I could just say years after 2006. So now, what point does this first row represent? Or what point represents that first row? That's a better way. Can somebody tell me? What point would I graph for that first row set of data?
0, 2006.
Yeah, 0, 2.32. I like it. Now, this is across the whole United States. So in California, of course, we laugh. Huh, less than $2? Woohoo, that's crazy. All right, ain't gonna happen. Anyway, so I mean, you don't have to, it would all be the same thing, right? It'd be 1, 2.27 and so forth. And then, now here's where things get interesting. If you have to graph this data, all right, you got to clear this away. If you had to graph this data on a chart, now they've already done this for you, which kind of sucks. But why did they choose this scale? What makes sense about the scale they chose? Or is there something that doesn't make sense? What's the highest value on the y-axis in the data?
For
Oh yeah, on the chart it's $4, but in the data.
The 2012.
It probably could have just stopped at 3.5.
Could have stopped at 3.5, but one reason I go a little further than that is so there's a little breathing room between the top of the graph and the top of the chart of the how do I say this? The top of your curve and the top of the graph. So it's not a bad idea. Give it a little bit of breathing room. But you could have stopped at 3.5 because there would have been a little bit of breathing. So how do I plot these points? Well, I estimate. So let me see if I can do this and keep all the data on the screen. Yes. So like 0, 2.32, I would estimate 0, 2.32 is going to be a little bit less than halfway. So it's going to be about right there. You guys with me? 0, 2.32. So it's going to be about right there, roughly. A little, no, it'll be a little more than halfway, Jeff. Did I have coffee this morning? Maybe. What would halfway be between 2 and 2.5? What's the halfway point?
2.
What's that? 2 point, sorry?
2.3.
No?
0.25.
2.25, right? It's halfway between $2 and $2.50. So 2.32 would be a little bit more than halfway. So it's not going to be perfect when you have to graph by hand these two decimal places. You're not going to be perfect, but please be better than just slopping it down. One will be 2.27, which would be just about halfway, little tiny bit down. And then the next one is 2 is 3.05. That's better. 3.05 is just above 3. You guys with me out there? A little bit? So it gets a little bit worse when you have to estimate decimals, but just do the best you can. You can even give yourself, you can even identify halfway points for yourself so you can be a little bit better. All right, maybe. I'm not going to do the whole thing. You basically do the whole thing. You do the same idea. Then you could very easily tell visually where is it going up, where is it going down, where's its lowest point. It's just easier to identify all those things if I graph it. Okay. Blah, 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 blah. Now, let me see if they do this for us. Barf. No, 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 no. So this is just more data to get some ordered pairs from. Darn it. I was hoping they would do, no, I guess not. No, barf. All right, and then here comes the let's look at the homework. Let's see what the homework's gonna look like. Yeah, love it. So this is just like the problem we just did. Be very careful on this. Use hours after midnight. So let me help you guys out. I'm sorry, Genius, what's up?
I have an ebook, and for some odd reason, my graphs don't show any numbers.
Oh, like right here?
I thought it. Yeah. No. To the side. Time, temperature.
Oh, here.
Do I have to find that? Because yeah, I thought it was just
you're gonna
one
need
page.
this.
Okay. I'll just take a snapshot because I'm on my phone.
Oh, you're not gonna be able to get the whole thing. Hold on.
Okay.
I don't know if you all even read that. Okay. That's a problem. Are you using Kindle?
I have Kindle.
Yeah, me too. So I don't know why it's not able to do that. That's weird.
Yeah, and I went to the other page. It's showing up for all the graphs. That it's all blank.
What do you mean? It's let me see.
So
yeah,
there's no. I mean, so like even on the previous ones, I just have data that's not inputted. I think that like the previous page that you were on.
In the table.
Yeah.
Oh.
Yeah, in the tables. I didn't have any data inputted, so I just took a couple snapshots.
Oh shit, that's gonna make things difficult for you. I don't know. If it's Kindle, you might want to. I don't know how to re-download on Kindle. I don't know.
I'll look into it.
Okay. All right.
Okay.
So real quick, what would this first ordered pair be?
Zero comma 61.
Yes. Since it's hours after midnight, at midnight, I'm 0 hours after midnight. So then this will be 1 comma 63. Easy. And then you have to plot them. Now you have to pick your own scale here and your scale here, correct? So I'm going to let you guys think about that. Yeah. So you want to consider the fact that you want to get up to about 81. So you don't want to have 80 show up like right here. You want to make it so that 80 shows up here somewhere. So you got to think about what scale is going to let that happen. Okay, maybe. And they're forcing us to start at 0 here. So they're trying to make this difference. Now watch. I want to show you something that's going to happen on a problem here. Now look, they're going to make you do the same problem again, but now you're going to start at 50. So now it's going to be able to open it up a little bit more. So you can see the differences better. So so in this first problem, they want you to start at 0. You guys see that? They want you to start at 0. And then they want you to do the whole thing again, but start at 50. Start at 50 here. Okay, maybe. So we'll see how that goes. So the first like 7 problems are plotting points and then looking at your graph. So see where they say, where was it decreasing? You just have to tell me between this time and this time, the graph is going down, right? That's decreasing. Okay, how's everybody doing? Same thing for increasing. Okay, nothing too crazy. And you don't have to use these. You could use your own graph paper. Okay. I like it. All right, so nothing too crazy there, hopefully. And then it looks like we're about to get into some stuff to do with percentages, fractions, decimals. So this should definitely be a big time review. We talked about this stuff earlier, fractions, decimals, percentages. All right, I'm hoping. Because the next thing we're getting into is probability. And probability it gets a little freaky sometimes. Yes, that's coming up next. Let me see what time we got. Not enough time to get into it. My little brother, I love him to death. He says, Jeff, do you still teach probability? And I say, yes. And he says, what the hell? Either it's going to happen or it ain't. Everything's 50-50, Jeff. And I'm like, James, don't become a doctor, dude. Please don't. I don't want you to tell me I'm going to the surgery. What's my chances, doc? 50-50. I don't want to know. Right? Unless that's true. But I'd rather know you have a 95% chance of survival, not, you could die or live. Who knows? So there's probabilities are misunderstood. They're so misunderstood. But they're so useful if we use them correctly. So that's the next thing we're going to get into is probability. Okay. So obviously that's why we're doing a bunch of decimals and percentages practice. All right. I think that's enough for today. What do you guys think? I think so. So the quiz should be open now. If you want to go start it now, you can. The minute you start it, you get an hour. Do not forget to submit the scanned work where it says submit quiz 1 here, correct? And don't do it like an hour after you finish the quiz. Do it immediately. If you have technical difficulties, email me the quiz and then keep trying to upload it into Canvas. If your Wi-Fi goes out and you started the quiz, just get in touch with me as soon as you can and we'll figure something out. You guys all with me? Because this new era we're in sucks, but we do what we can. Okay. Let me know if you guys have any questions, if you need to hang out for a little bit. Otherwise, you are free to go. Oh, did you guys see the thing about the extra office hours? right? So I have extra office hours today and Thursday if you want to come.
Yes, thank you for that.
Sure. All right, guys. Let me know. Genius, you have another question? What's up? Or is that from earlier?
No, that's for right now. It's just I was wondering if you can just go back to the page that I think it's part of the homework, the 12 a.m., 1 a.m., the scale.
Yes.
I think it's page 71. That's what I'm on. Yeah, 71.
All right, hold on. Oop. All right, here you go.
Okay, sorry. I was trying to figure out my book and why it wasn't showing. So I guess wait, I'm just trying to see it. Does the top, it just starts at the hourly temperatures? Is that the top of the page?
Say again, sorry.
Oh, okay.
Hourly
I was just trying to make sure that was the top of the page. Because when I was looking at it, it looked like it was cut off, but then I took another picture of it.
Okay.
Okay.
Yeah.
Okay. I think
you can figure something out because that's good. There's a lot of tables in this book, so that's gonna suck if they're all blank.
yeah, I've been skimming through the book and trying to like read ahead, and I've noticed that some are off. So I'm gonna see if I can re-download it, so I don't have problems. Okay, thank you.
Sure. Everybody else okay? All right, I'm gonna head out. I wonder, are all of you out there or some of you guys back in bed? What's happening? I'm gonna head out. I'll see you guys.
I'm here.
Oh.
I was just sorry. I was doing something.
You're good. All right, I'll see some of you guys later today and the rest of you guys tomorrow morning.